Hey everybody, so for this week's video, we're going to make a video on our discharge experiment, and it's supposed to reflect off of our lab report, so here we go. So, introduction. So overall, this experiment was very time consuming, but it was very interesting as well. It was made you go out and actually understand firsthand what the whole experiment was about. So I picked a stream close to my house. It's called Cranberry Creek. It's located in Ravenna, Michigan. The goal of this experiment was to find the discharge of two parts of the stream. So I picked two different parts of the stream. This was done successfully by finding the cross-section area and the velocity of those two parts. And they were pretty different, and I picked two different parts, and by doing that I was able to specifically change the width as a variable that was purposely changed, and I picked a skinnier portion and a wider portion of the stream to do that. This is not a very big creek as well. The deepest points don't even reach a foot in depth, so I'll give you an idea that it's not that deep. Alright, so for methods, the materials needed to do this, it's not really complicated. They're simple tools. All you really need is a tape measure, and then you could go barefoot in the river, but it's probably pretty cold out right now to even do that. But I had waterproof boots. I brought over my notepad and a pencil so I could write notes and measurements and anything I needed on the way I would write down. It's nice to have a partner, which I did. But if you don't, you could still do it. You just have to get in the water more often. And then I brought my phone for timing and then take pictures like that on the left. So the first thing I did was this on the first section. I would measure. I always measure the width first, not a real reason, but I just would. So within a 10-foot section where you would measure your velocity, I would measure 3 different sections of width. To get about an average width of that section of that part of the stream. So just like this tape measure here, I'd measure across to where the water starts and then where the water ends on the side I was on. This is it's usually I would have my partner go on the other side and hold that, so it's pretty accurate. I just had that person move so I could get a picture or just represent what's going on here. And this gets a more accurate measurement if you have a partner as well, because they can actually make sure that it starts exactly where the water starts. And then the second thing I would do is I would measure the depth. So this actually might require you to get in, because to get a more accurate measurement, I'd have my waterproof boots. I'd walk in the river and measure different sections throughout that area, because of course in the middle it's going to be a little bit deeper than it is when you get closer to the sidewalls of the stream. So I measured around to get an accurate average of those different parts of the stream. Another part you needed to do was needed to measure velocity. So for that, I would stretch out the tape measure about 10 feet. Then I would have my partner. I'd usually have my partner stretch out the tape measure. It's not really that good of a picture. It's all stretched out and stuff. But I'd have my partner stretch it out 10 feet, and then I would drop the stick in at the beginning and time how long it would took the stick to go 10 feet, and I would use that to find my velocity. I'd do that by using the length divided by the length divided by the time, and then you find how many feet per second it takes the stick to go down the river. Alright, so these are my results. Up here it just shows you the width, the average, the depth, and the average of the different sections and how many of the trials. So I did 3 trials for each, and I'll tell you the average. I did that I show you here the width, the depth, the time, and the velocity trials and averages for both the sections. I actually did the trial. When I did the trials, I recorded them in inches, but once I found the averages, I changed it into feet, because you needed that later on to do some of the calculations. Down here, I just show you in depth of what numbers I use to find what. Like for example, the cross-sectional area. Use the average width multiplied by the average depth for each section, and this is what I got, feet squared, and then that feet squared. For discharge, take the cross-sectional area and multiply by the velocity of the section. So I did. This is the velocity. This is the area, the cross-sectional area times the velocity right here, and then you get feet per second. How many feet per second? That's how much discharge there is. It tells you how much discharge. And then these are just two more charts. This is cross-sectional area chart, and this is my discharge chart, and this is my cross-sectional chart. It shows you the average between the two sections. So my interpretation, before I did last week, we kind of just did an interpretation, and my interpretation was that the discharges would be a little bit different because the widths and the depths were going to be way different, and the velocities were going to be different. But I did say it'd probably be close because since one part of the river was going to be deeper but skinnier, and the other part was going to be wider but shallower, it was going to even out, but it would come down to velocity to be the difference makers between the two when it came to the discharge, and that is what happened. So in the future, you could probably do more sections than just 2 to record data, and I only did 2. You could probably do 3, maybe 4. You could probably also do more than just 3 trials to get an average. It'd be more accurate. I only did 3. You could probably do 4 or 5. It'd take a lot more time, but you'd probably get more of an accurate average of that part of the river or stream or creek. You could probably have I probably could have had better planning to get more in depth. And then the creek I did choose had a bunch of rocks and, not rocks, it just had a bunch of fallen branches and logs that made us change the velocity a little bit. And that's all I had. Thanks for watching, guys.